Hello, everybody. Today we're going to present the findings of our business case for Spotify. First of all, it is important to explain why this would be important for Spotify to learn about our analysis. And we start by first stating why we did this. We wanted to learn the impact and the importance of variables in the data set from Spotify to drive success in the songs. And the way we did this is there was a column in the data set called popularity, and whichever song had a popularity over 50, we'll consider that successful. And we thought that this was important for Spotify because we thought that the more successful songs there were, the more streams there could be in the platform. This could also mean that there is going to be higher user engagement and therefore user retention for the app. And this could also drive stronger artist partnerships and platform growth. And we're going to start first by explaining our data analysis and the approach we used. So again, we use the data from Spotify that tracks all the songs even back to even 1920 that were released. And it includes different variables and features for each of these songs. And we analyzed it using different methods. We first, of course, cleaned and explored the data, and then we built a decision tree, a random forest, a neural network, and a forecast model using ARIMA. Now, when we built our decision tree, we got an accuracy of 0.82, which is very high. And then when we analyze this tree, we see that explicit songs with high energy, early month releases, and subtle loudness have the highest success rates overall. So we see the hierarchy among those variables. And now, when we move on to the random forest, we built and tested 20 different random forest models to try to explore a way to improve the previous model accuracy. However, the change is very low. It went from 0.82 to 0.83, which is still very good. However, the change is not as important. But we did see some changes in the variables. We saw that loudness, duration, balance, energy, and danceability were the most important features for these models specifically. And this is very interesting because it's giving us more room for us as a Spotify to give recommendations to artists that want to improve their probability of success anytime they release a song, right? So this is very interesting. It is important to note that we did build a neural network. However, due to computational power, it did not run in our computer. However, we would have liked to see the results if we would have been able to. We wanted to compare all the different variables, and this was just not possible in our computers. Now, when we move to this projected song success rate, what we did here is we built an ARIMA forecasting model. And the reason why we did this is because we wanted to understand how the platform and the songs were doing in terms of success compared to the overall songs that there are. So what we did is we measured all the songs that were released in a month, and then we compared out of those how many are successful. And that gives us the rate of success. And you can see from 1970 until 2021, the blue line has gone up. So there is a positive trend. Now, when you look at the green line over here, you see that our forecast still shows that the positive trend is going to continue. However, at a slower pace than the blue line, and it shows the confidence intervals, which are the gray lines above and bottom, which can be that within those ranges the forecast can move around. And this is very important because it enables Spotify to set data-driven performance targets. And we also used PACF and ACF to choose our AR and MA lags. And this can be seen in the appendix in case you want to take a further look at that. And this is going to help us build the recommendations from Spotify view to the artist. And the idea is to improve song success on the platform. And we want to recommend Spotify to encourage artists to release tracks between spring and early fall, especially on weekdays like Thursday or Friday when success rates are historically higher. The time series data shows consistent drops in success during winter. This can be seen again in the appendix when we did the differentiated part of our ARIMA. And we also want to avoid that period because we want to boost visibility. There are some key audio features that we want to recommend our artists. So we want loudness to be below the minus 0.98. We want to focus also on duration. We want the balance to be positive. We want energy to be greater than 0.88, greater than or equal to. And we want to also focus on danceability. And the idea behind this is the more hits we get, the more engagement we get. And that means a win win for artists and for us. And the way we want to target how our recommendation is doing and the success of it is by first sharing insight with the artist. We want to provide database recommendations to guide song production. We want to monitor results, which is very important. And the way we want to do this is tracking success rates, benchmarking it to our forecasted numbers, which are right here. So, for example, for 2021 in May, if the success rate is above 38.6%, then it means that maybe our recommendations are having a positive impact. And lastly, but not less important, we want to continue refining our models. So we want to continue updating insight as new songs and trends emerge. We hope you like this presentation and you find it useful. Have a good one.